come from only from variable beta 1. That's why uh, yeah, it is equal to the variance of equal to the variance of beta 1. So, is there any questions?
Uh, Sir, why is the why is the variance is not equal to the mean of y subtracted by the mean of x times the variant of b1? Well, we could
Okay,
say that it's equal.
okay. Very good questions. Actually, that's because the y here, the variable y and variable x is constant. Is constant. Since constant, yeah, in this equation, yeah, we limited discussion in the equations, yeah. Since the actually coming from this expression, you can prove or you can check based your maybe software you use to plot for or from many literature that you can search from the internet or maybe in many source, that the beta 0 is equal to uh, this one and then we can express or manipulate become this expression and these expressions. So and then since this how to say random variable, since this random variable for the beta 1, so we only consider this random variable, and then the variance, actually the variance is taken from random variable. There is no variance in constant variable, yeah, there is no variance in constant variable. That should be point out. So in this case, the variance of beta 0 equal to the variance of uh, beta 1.
So because it's constant, so that it is equal.
Yes, because why because this y is uh, average and this x is average, something like that.
Okay, sir.
Okay, I hope it's answering your uh, questions. Okay, I need to save and then I can share with you later. Okay. Okay, any other question? Yeah. I'm very I'm very much understood. Yeah, I'm very much understood that maybe this topic might be a bit many very much mathematically, very much mathematics. So yeah, yeah, maybe it takes time to maybe to understand something like that. And I yeah, please be how to say, please be eager by yourself and then conduct the assignment or exercise. Okay, if there is no questions, we let's move forward to the next subtopic. Subtopic, yeah, subtopic. Uh, Actually, I have a case here. Uh, we have the data. For example, this case. This case will bring you to the topic of correlations. Correlation between data. Yeah. In this case, correlation between sorry, correlation between X and Y. Okay. Uh, so in this case, we have experimental result as shown in table 11.8. And then if we assume that the relation between X and Y is linear, yeah, so we can express being like this. Please compute for beta 0 and beta 1. And then plot graph of this based on this data. And the compute correlation coefficient between X and Y. Ah, please find the formula, mathematical formula, how to compute correlation coefficient from given sample. Yeah, you can search from the internet how to compute this. Please, how to say? Please write the formal formula. Yeah, the formal formula. Yeah, before you directly compute and get the value. Okay, and then please inspect or analyze whether the correlation coefficient is equivalent to the beta 1. Based on your analysis, explain if it is equal, why, and if it is not equal, and then why, something like that. Is that clear?
Clear, sir.
Okay, please conduct by yourself, yeah, by yourself, maybe in 30 minutes. 30 minutes. I will send you as well about this one. Maybe if there is a connectivity problem about my screen, and then I can as a backup. Yeah. Okay. Probability. Okay. Probability and statistic, and then I will send you this slide. I mean. Okay. Okay. Enjoy your time and conduct the exercise. Okay, everybody finish? Finish or not yet?
Sir.
Let's go.
Hmm? Okay, maybe for yeah, just exercise.
Sir, I think I got the answer.
Oh, okay. Edro, yeah, Edro. Oh, Edro. Okay, thank you, Edro. But this time I will ask maybe Mikhail Fauzan. Can you show me, show us lah, yeah, show us
Okay,
your
okay. Sure
your
can do, sir. Sure can do.
yeah. Good, very good. Okay, now I already allow you to share screen, maybe.
Eh. Okay, okay. Wait just a second. Wait, what? Can you share the screen the question again, sir? I forgot all the question.
Uh,
B1.
okay. I see. I think that I already
Oh
sent
yeah, yeah. From the WhatsApp, I
this
forgot. Forgot.
WhatsApp. Yes.
Okay,
Okay.
nice. Hmm. Okay, so sir, I searched the calculator to search the what? First,
Okay, good.
you ask us about the what? The B0 and B1, right?
Okay. Yes.
So after I put the data, we
Okay.
get that B1 is 3,884,
Hmm.
while the B0 is negative to 25,433.
Okay. Good.
Okay. After that, you ask us about the graph, yeah, the plot the
Yes.
graph.
Yes.
And actually, this is the graph. Is it acceptable, sir? Like this?
Yes. Yes. Okay.
Okay. And after that, you ask us to compute the correlation coefficient.
Okay. Yeah.
And from what I searched, I got the wait. I got the the what the equation of the correlation coefficient. Wait.
Actually,
Ah,
I
this
was
this
okay.
the 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 equation that I use is this the correlation coefficient.
Okay.
Okay, so I get that the R is 0.893.
Okay.
And then you ask us about is the correlation coefficient equivalent to the B1?
Hmm.
And I say it's not equivalent to the B1 because the B1 is 3,000, right? And why
Yes.
is it correlates? Because the B1 represents the gradient, right?
Okay.
While the correlation coefficient represent the relationship between X and Y.
Hmm.
Let's say if the correlation coefficient is close to 1, then that means when X getting high, the Y is also getting high with the same value. Like for
Hmm.
say if the correlation coefficient is 1, if the X went above 1, then the Y will also go above 1. Can you get it, sir?
Okay.
Okay.
So so
Yes.
so in this
So
case, the correlation coefficient is
not equivalent.
not equivalent. So
Yes.
equivalent. How about the value? The correlation coefficients?
Or it's the wait. This sir,
0 point
0.7974.
7974. Okay. So okay. Very good. Okay. My question is, uh,
Yes.
what is the range of correlation coefficient
Oh, you
values?
mean I think it's 0 to 1
0
because
to 1. Okay.
yeah, because correlation, right? Speaking of
Yes.
correlation, cannot be 0 because then if 0, then there's no correlation at all. Like yeah,
Yes.
but
Okay.
it cannot go above 1 because one cannot be multiplied more than one, right?
Yeah.
It's my logic is that, sir.
Okay. Okay. Very good. And then your answer is not mistake.
Okay.
But what happen if I have, for example, like this one, and this is y, and this is x,
Yes.
and maybe supposed to be the line is being like this. Uh, what what do you think about the correlation value?
By what do you think? I don't quite understand, sir. You
Okay.
mean like
I
if
mean
it's
the
yeah.
value is what to say. You can see from the graph
Mm-hmm.
uh, how we can say about this graph related to
It's
the x and y variable
decreasing, sort of like
decrease.
decreasing. Yeah.
So when we increase the number of x, the y is decreasing.
Oh yeah. Oh yeah. You're right, sir.
So
So that means that means means the correlation is berbanding terbalik, ya, sir?
yeah, berbanding terbalik. Berbanding terbalik, it's mean that the correlation is positive or negative.
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 Oh, it can do that. Okay, sir.
Okay, this
Okay.
correlation, this is negative correlation.
Okay.
And if one say there is no correlation, it's kind like this.
So that's zero, sir.
Yeah, zero.
Okay.
Okay, yeah. So
Mm.
what you can conclude,
Uh,
the range of
correlation.
the range
The
of
range is negative infinite to to infinite. No. To yeah.
hmm?
Right. The correlation
Yeah, the correlations.
negative infinite to infinite.
Are you sure?
No, I think.
Yeah, actually from -1 to the +1.
Oh, okay.
That's
Because you cannot go above one.
yes.
Ah, okay. Sorry, sir. Okay.
Okay. Can you prove why the correlation is not greater than 1 or not less than or -1?
How to prove it? Yeah.
Yeah, that's my
To prove it.
question.
To prove to prove. I'm kind of confused how to prove because like
Okay.
it's just in my logic, like, sir.
Yeah, no problem. That's your logic. That's good. I mean, that's
To prove,
initial.
yeah. Good
Uh,
question, sir. Good question.
yeah. Okay. To everybody, yeah. This maybe it's kind of first assignment to this. Please prove why the correlation is only belong to this value. Actually, this is clue. You can start from the standard no, the variance of you can manipulate between the variance of x, variance of y, and the cross not cross correlation, but how to say how to say this is xy variance, xy variance. Yeah, actually, it's belong to these three variable. So okay, you can check by yourself how to prove this uh, value. Okay, you got it, everybody?
Sir, I have questions, sir.
Yes.
Then what is the difference between correlation and the B1, the beta one?
No, okay. The actually, if you see, of if you how to say, make an experiment, for example, making the linear regression, and then you can cut these equations. Let's say b0 plus b1, and this is the x, and you, for example, you have the data, and you will get the result, the b1 either being negative or positive. Is it correct? You got it?
Yes, sir.
And then it's reflect to the correlation. For the correlation, if the b1 is negative, the correlation is should be negative, and the if the b1 is positive, correlation is positive. But for the value of correlation is only limited from 1 and minus, from -1 to the 1. But for the b1 or beta 1, it's going to be from the positive infinity and the negative infinity, something like that. Actually, there is a relation between the correlations is a function of beta 1. The how the functions, actually this also how to say, a function of uh, this variable. Yeah. So number two, sorry to uh, please find the function of b1 so equal to the correlation, something like that. Actually, before you asking, I will give you this assignment for number two. Okay, you got it. But this is not difficult. You can search by the internet, but you have to manipulate between three variable. These three variable. Any questions? Don't be afraid to make a question and then will be Simon. No, no, no. Is there any questions?
Wait, sir, just to make sure, standard deviation cannot go above 1, right?
Sorry, what?
Standard
What?
deviation cannot go above 1, right?
Standard
Eh,
deviation.
yeah.
Yeah, standard deviation. Oh, no. Standard deviation, it can be.
I mean variance. Can?
Yes, it can.
Ah,
It
okay.
can. It can. The variance can. It can. The variance is. The variance it should be, yeah, between 0 until in infinity, actually, yeah, because you can see here this is square 2, yeah. So it's not possible the variance is negative, as well as for the standard deviations, because the standard deviation is just square root of variance. So is that clear?
Yes, sir.
Okay. Okay, I will give you the picture. Okay, so Mikhail, any questions? No?
Yes. I think no, sir.
No? Okay. If no, wait a moment before you close. Actually, I would like to show some things. You can see here, the Mikhail already have a result for the correlation coefficient is 0.
Oh,
Yeah,
okay.
0.7974. Okay, that's good. Actually, it's correct. But please look at to the graph. Can you show me the graph?
Wait,
Yeah, that's good.
or
But
here, wait.
wait, ma.
Here or here, sir?
This
Which?
one, this one is better.
Okay. Okay.
Okay,
Okay.
okay. You can see here that there is some deviation. You can see here
Yes.
that looks large, right?
Yes.
Large. Uh, do you think that this relation between x and y is linear? Linear.
Not perfectly linear, but I think linear, sir.
Okay.
Because it's just one or two, right? The deviation, not
Okay.
that much. Okay.
Okay. And first, when you model this data become linear, and you got the correlation coefficients become
7.7974.
0.79, yeah, 74, yeah. Uh, 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 what do you think? How to say? How to maybe improve the model? I mean, improve the models become non-linear. Uh, what do you think? Maybe like this. Okay, maybe, yeah.
Yeah. Uh,
Okay, so supposed to be this data is non-linear, and then how to model this data? Any idea? Maybe I'm asking not only for Michael, but maybe the others has an idea. No idea.
sorry, sir.
I guess not, sir.
Okay. Please consider if the you can see here that the the data this model we got the b0 plus b1x. Please consider for the y here y is how to say yeah. We consider another model, so we use g equal to something. Actually g is uh, learn y.
Mhm.
Learn y and compute the correlation coefficient. You got it, my questions? No?
Still don't get it.
Huh?
I still don't get it.
Okay. From this data, maybe from inspection by manual inspection by looking at this data, modeling using linear seems to be maybe it's good, but maybe we got a large deviation in some point. Agree?
Mm, okay.
Okay. And then can we consider to non-linear model? Non-linear model maybe it's not only y plus no non-linear model. So instead of y equal to b0 beta 1x, we can use a non-linear model. Maybe it's like learn y equal to beta 0 beta 1x. Actually, learn by this equation is no more linear, right? No more linear. Learn y equal to beta 0 plus beta 1x. Okay, right now please conduct, instead of original value, original value, please before we put this value into this calculator, please compute the g instead of y. The g is learn y. You got it?
Sir, I have questions, sir.
Okay.
Why
Me
it
too,
should
same.
be why should be learn?
Why should be learn?
Yeah, why not? I mean, like other equation, why it's learn?
Yeah, that's very good question. But right now, I cannot answer because the point is not why should be learn, but the point is how to transform. Yeah. Finally, I will. I tell you that actually in this case, I will let you know that we can model non linear model, non-linear into linear model. Okay, something like this. We want to transform again. We want to transform non-linear model to linear model. Yeah. So please compute learn y, and then the result submit to this uh this this how to
Oh,
say this filler.
so we search for the len of all the y values and then we put it there.
Yes. How?
Oh, okay.
You can use
See,
Excel.
Okay,
Excel. Copy this one and then learn. Maybe this column. Maybe this column is A. Learn A and then enter. You got
okay,
this
okay.
value and then you can put here.
Okay, sure.
Okay.
same. We use learn y for nonlinear only. Yeah,
Yeah.
yeah,
So
yeah. Kan?
yeah,
Make,
yeah,
just
yeah.
making sure, making sure.
Yeah. Make sure. Yeah. That's correct. I mean, just make it operation of learn y.
If non-linear.
Yeah. If actually it's not only learn y. Actually, it can be any other computations. But in this case, please just follow first follow my order. Later, I will conclude. Yeah.
Understood, say
Yeah.
understood.
Yeah. Yeah.
Should I stop the screen, sir?
Uh yeah, no problem. But maybe you can directly how to say
Or
prac-
let me just freeze the
practice.
screen again.
Yeah, practice. Yeah.
Yeah, let me freeze the screen.
Yeah. This is the type of plot discussed in section A, in which okay. Sorry. Finish? Everybody finish? Or Michael finish?
Wait, sir. Still making the learn.
Learn, okay. I think it's not so difficult, yeah. You just using syntax learn maybe. Learn or look using Excel. I'm not sure that the formula in Excel how to use learn.
Don't know how to.
L-
I don't know the formula of Excel sir. For the
Oh,
for
really?
the learn of Excel.
Okay. Let me help maybe. Just equal to
Learn.
ln.
Oh, okay. Just that.
Yeah, yeah,
Oh, okay.
ln.
Okay, okay.
Okay. Yeah, it is very simple. Okay,
Wait,
finish.
wait. This is.
Why did you take so long?
I just paste the. Wait.
Okay, no problem.
And here. Then copy, right? Copy. Paste.
Hello?
Sir?
Not finished?
No, sir.
Yes?
The it. Yeah. Let me resume my screen.
Oh, okay.
The I cannot
Okay.
directly estimate from the calculator, sir. I must
Oh, really?
mesti dirapihin dulu. Karena dia koma-komanya banyak kan, yang beda-beda.
Oh, beda ya.
Eh.
Oh, gitu tuh ternyata. Itu koma kenapa, Pak? Oh, iya,
Ini beda.
betul. Kamu
Kan
pakai
di Excel kan dia ini. Di Excel dia komanya koma itu. Sini koma
I
kita
see.
titik gitu.
I see. I think your setting is still in Indonesia, ya.
Ya.
Oh, I see. No problem. You really love Indonesia. Thank you. You should pass the tes wawasan kebangsaan.
Tes apaan tuh, sir?
Hah?
Tes apaan? Wawasan kebangsaan.
That's just joke about the the current situation in KPK, you know?
Oh, iya.
Yes,
Oh,
sir.
iya.
Yes, sir.
Alright, sir.
Yeah. Maybe your father is a leader of KPK, ya.
No.
I don't know. Yeah. Sorry for joking.
Yeah.
Sorry.
No offense taken, sir.
Okay. finished? Oh, not yet.
Maybe the others have already finished. I don't know. Maybe
Yeah, yeah, yeah.
I'm taking quite a time over here.
Okay. Okay.
Mm, Okay, that's hope works. Okay, sir. There you go, sir.
Okay.
Ah, there
Okay,
you go.
good. So, what is your conclusions by looking at the new graph?
My conclusion. I guess this time, I think there's there's like one of them is like has a high what deviation again, sir.
Hmm.
Like the previous one has one high deviation, right? But
Hmm.
in this one, it also has high deviation,
High
like
deviation.
some of the data, not
Okay.
all, yeah, but some of the data.
Okay.
But I guess it's smaller than the first one, yeah. I guess.
Smaller. Yeah, okay. What kind of parameter you can say smaller?
Or just just my eyes, sir. I don't know.
Okay, okay. Can you
Okay.
compute for the coefficient correlations?
Okay. Wait, sir. Whoa, dangerous. Let me reset this first. Hmm. It's 0.5, sir.
Are you sure?
Yeah, I
Smaller.
put yeah smaller. I put the R is 0.73 and the R square is 0.534.
Hmm, I think you made a mistake.
Really? Really, sir?
uh,
The I just put the values from here to here, right?
uh, uh,
That's how it works, right?
yeah.
I don't know.
Uh, Correlation is.
It's the same, the data.
I see. How about the B one?
Ah, the
B one?
B. The B1, the B is now 0.1256.
Yeah, it should be correct. And it's for B zero is
Oh,
speed, right?
let me check from the another calculator.
Oh,
Okay, wait. Mm, Oh, it's the R is 0.94, sir.
oh.
From this one. From this one, yeah.
That's
From this one. I
you you
don't know, sir.
you choose wrong calculator.
I think it's the same, sir. See, this Pearson, and this is also Pearson, sir.
Ah, but you have different result, right?
I don't know, sir. I don't know, sir.
Yeah, you have to ask the calculator actually instead.
Actually, sir, from what I noticed this calculator has this equation, right?
Hmm.
And in this, it has different equation
Uh, you,
from what I noticed.
okay, you have to ask the owner of the website. Okay,
Okay,
everybody,
let
please
me get.
refer to yeah. Everybody, thank you. Everybody, please refer to this one. actually we have a new coefficient correlation, right? That the higher than previous one. So what we can learn from this? What is the lesson learned from this? Means that the modeling, it might be, yeah, it might be. You can see here the the equation gives the higher correlations is learn y equal to b0 plus b1x, and actually this equation is not linear or non-linear, right? This non-linear, but you can see here if we replace this term using g, so it's like a g b0 plus b1 x, it's gonna be it's become linear. Okay, so the important thing that we can learn is non-linear 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 regressions can be transformed, yeah, transform into linear regressions, yeah. We can, or opposite, yeah. We can transform depend on the model that we can improve the accuracy or improve the correlation, something like this. So maybe another some of you asking about what kind of function that we can transform into how to say, into linear and non-linear. Let me show something.
Should I
Okay.
stop the screen, sir?
Yeah. Okay. Thank you,
Okay, okay.
Michael.
Yes, sir.
This is linear, non-linear, linear transformations. Okay. You can see. Oh, I'm not yet. Okay. Can you see my screen now? So you can see here from my screen that, for example, first is exponential function or exponential formula. You can see this is y and this is x, this is x, and it looks like non-linear, yeah, non-linear. But we can transform it to linear equations by making learn into the y component. Okay. Also for the power, yeah, power, this is y and this is x here. This is the variable x. And then we can transform it using logarithmic functions, and then it's become linear. It's also is like reciprocal. Reciprocal, you can see this is y and this is x here, and you can use just this equation, this expression, one by new variable, and then you can get the linear expression of uh, this function, and all, as well as for the hyperbolic. And then you can replace y using y plus y 1 by y and 1 by x using new variable. Maybe this is x, this is y. Actually, maybe this is g, yeah. This is maybe z, something like that. Actually, a new variable, and then you can uh, form, or you can express into linear equations. Okay, that's all our class today. Yeah. Is there any questions? No questions. And because right now in my place, in my home, already maghrib, yeah, it's time to pray for the Muslim, and so I finish our class today. Thank you very much for your
Thank you, say.
attention. Yes, and don't forget to conduct the assignment, yeah. Assignment, there are two assignment proving, I forgot. One of them is proving function between coefficient correlation and beta 1 variable, something like that. Okay, you can check in my video that I will upload in YouTube and let you know. Okay, thank you very much and see you tomorrow. Yeah, stay healthy and stay protokol kesehatan. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir.
Thank you, sir.
Thank you,
Yes.
Thank you,
sir.
sir.